Alright, I've got a Pi4 set up with the latest DragonOS Pi64 build, actually the beta 4 that I've uploaded, and some more fixes in there and some tools that I wanted to talk about, mainly the Kismet or kisStatic2Mobile. And so for anyone familiar with Kismet, you can run Kismet or you can run Kismet Remote, the remote capture tools on small devices like OpenWRT or in this case the Pi. And so you don't have to run the full Kismet server. Instead, you just run the remote capture tools and then you can send that information over the network back to the main Kismet server. The problem has been that you can only, it's only meant really for stationary devices because you were only ever able to set fixed GPS, which really doesn't do you any good if you want mobile, say, Pi4s moving around, maybe doing some sort of um, survey or wireless intrusion detection, something maybe of that sorts. Um, so it was really kind of annoying with just fixed GPS, and but now, thankfully, this kisStatic2Mobile tool, which is a TCP location updating proxy for Kismet Remote, now can take into account GPS from GPSD. So in this Pi4 I have in front of me here, I have a USB GPS device plugged in, which I can see under Dev, and it's typically going to be TTY USB 0, which we see right here, which lines up with the default GPSD. So if it's something different, if you have multiple plugged in or you unplug it, plug it back in, you might find that it's TTY USB 1. But this is set up to start on default. The Raspberry Pi images, if you have a GPS USB device, you should be up and running. And so what we're going to do is we're going to go to the user source, kisStatic2Mobile, and what this proxy is going to do, like I explained, it's going to run on the Pi and it's going to listen for Kismet remote capture tools. You can start multiple devices, Bluetooth, wireless, whatever, up to 5 I think it is by default, and send to the proxy instead of the remote Kismet server. And then what's going to happen is the Kismet proxy will send the information onto the Kismet server with the real GPS locations of the devices. So off screen here, you can't see it. I have another laptop running Kismet, and that Kismet is set up to allow incoming remote Kismet remote devices. So you're going to have to take care of that part as well. And then all you should have to do on the Pi here, if we take a look, you don't even have to set relay the listen. We can leave it at the default 127.0.0.1.3500. But what we're going to do is set the send IP to the IP address of the Kismet server that's also on the same network here, and port 3501. So that's going to connect to GPSD and it's going to listen, and then it's waiting for us to start up a remote capture tool on the Pi. And I'm just going to stick with something simple here. The Pi has Bluetooth on board. Unfortunately, the wireless device, I don't have the Nexmon patches working, so you would have to plug in a USB device and figure out what interface name that wireless device is. But for the sake of this, we're going to do Kismet Cap Linux Bluetooth, and the key things that we need are going to be connect. We need to make sure we use the legacy TCP connection. We're going to do a source, and we're going to do a fixed GPS. So it's going to be like this. We'll do -- connect, and we're going to put in that 127.0.0.1.3500 and not the Kismet server, because we're going to send this information to the proxy. Then we need -- TCP. We need, let's see, -- source, and for the Pi's default Bluetooth is typically HCI 0, and we are going to set a fixed GPS of really anything we want, because it's going to be replaced by the proxy with the real GPS information. So we got all this. I hit enter. Now we can see we're connected to the proxy. We're capturing. On the left, it's passing the information onto the Kismet server with the GPS information. I look over to my right here at the laptop, Kismet in the terminal, and I can see that the Bluetooth devices that are being identified are in fact being sent across. If I open up the web interface for Kismet and I go and I double click on any of the devices, you can go down, you can see more information, and in that additional information, instead of the static IP address that we've been stuck with in the past, or the fixed GPS, we now have a real GPS location. All right, so that's to me, that's like a huge plus for Kismet and Kismet Remote when you're not wanting to run full Kismet instances on all your remote devices, and you want them to be mobile. So, anyways, all right. So that's that. We'll take a look at something else that's included in the Pi build here. It's even included in the main DragonOS Focal. But what I had to do for some reason or another to get it to work now, because there was an update in the kernel 5.4.0.10 or -1034. Once updated to that, and the firmware and some other things were updated, SDR plus, which I want to look at, did not seem to like the default. If we look in the boot firmware user cfg.txt file, it did not seem to like the fact that I had 4 settings here on by default, which really seemed to bump up the video or just the overall desktop experience of the Pi with the video acceleration on. So for this demonstration, I've commented these out, I've rebooted, and that does allow. So you may find that if you start your Pi64 build by default and you can't start SDR++, you may need to go into this file, comment these out, reboot, and then you will be able to start. One other thing I'll point out too before we get too far into this is if you have SDR Play equipment, because SDR++ has native support for SDR Play, you need to run the API installer, which you can do just like I'm doing here. The shortcut will take you to the same location. You just need to actually run the installer manually one time at least after you've booted up your Raspberry Pi. The installer will put everything where it needs to be. And once that API installer is finished, give it a little bit, and then you should be able to plug in your RSP1 alpha. And while I'm giving that a second, I'm throwing a lot out there. There's one other thing in the new Pi build while we're waiting, is the raspi.config tool that you're probably used to running in Raspbian or Raspberry Pi OS. I've got that working in this 20.04 base build, and the thing that it really helps with is under the advanced options, the expand file system. Now you can expand the file system just like you're kind of used to. You don't have to do a lot of stuff to get it working. You let it resize, finish, and I'm not going to reboot now because I've already done this and I know it works. As to whether or not all the other options, I'd be very careful with what you're editing with this tool. I don't know all the ins and outs of it. I just wanted to make sure that the file system expand portion worked. So anyways, that does work. Alright, so now we'll jump back. Let's take a look at, and you can see some of the artifacts here. Just saw it kind of over here to the left. It doesn't seem to work as well, like I said, with those settings off, in my case here, to start SDR Play or SDR++. So I'll take a look at the SOPI SDR utility. If you find that it hangs here, take a look at top. Sometimes the SOPI SDR server is maxed out for some reason or another, and probably because I didn't reboot, but you can do a sudo systemctl, and you can restart that SOPI SDR server, or if you don't want to be serving up your SDRs with the SOPI SDR server, you can stop and disable this service. Now if we look, everything's fine. I'm using VNC to connect to here. That's another thing. On the Pi build, I went ahead and included the Raspberry Pi real VNC server, so you can access the Pi remotely. The only catch is you really can't, unless you're already logged into the desktop. If you remote desktop, you really can't get in unless you drop to a terminal SSH in and do some workarounds, but that's for another video here. Anyways, now if we look at SOPI SDR utility, we'll see I've got both a HackRF 1 and SDR Play equipment plugged in. Now we'll start up SDR++, either in the terminal or over here. Link works. I have found, and it may be something that I'm doing, the straight dedicated HackRF module for me closes SDR++ out. Not 100% sure why, but if I open up the HackRF one with the SOPI, and you can change all these settings, I do find that that works. And if we change over to the SDR Play, we now get dedicated native SDR Play access here with the SDR++ application, which I find to be very efficient, and even more efficient when I'm able to use the video acceleration, or maybe it's something to do with OpenGL. Works really well. So anyways, this is the RSP1 Alpha, and I'm pretty excited to see all the new features that SDR++ is going to start rolling out. So that's just a quick look at that and how to get that running if it doesn't start for you. Let's see, another thing, if you've hung in this long, a lot of people seem to be interested in, if we look in the user source SigPloit, we can see that it is in fact installed, and we can run it. Well, there's a couple things. Matter of fact, I'll link to a video that'll pop up on the top at this point in the screen, and you should, I haven't gone through and tested all, you should be able to follow another video, but in this case with the Pi, and if I get a chance, I'll check it out. But there's a server side to this, so you should be able to use Java and start up the server side, and then you should be able to start up the client side of it, and then you can work with SS7 GTP diameter and SIP. If we just take a quick look, SS7, do location tracking, and anytime, and you would have to set it up just like the other video that popped up, and you should be able to interact with the server side that comes with it. Alright, that's a lot of stuff, but there's a lot in the Pi64 build, and a lot more that I want to include, as long as I can keep the size of the image right around 4 gigs or so. It suddenly got a little bigger after some updates to the kernel, so I'll have to figure out how to keep that under control. Alright, thanks.